let's start this now. So understanding data science roadmap. So I place this talk into 3 different levels. One is a very beginner, someone who is just excited to get into this field. So first session is based on that. So if you're inspired data analyst or a software engineer or just a graduate, this is a roadmap which you need to follow. And you can Google this by saying that data science roadmap, and you should be able to find this in the Google images. If not, just drop a message and we'll send you this one. So step number 1 is go through your fundamentals of mathematical, hashing, binary tree, algebra basics. Then number 2 is learn stats, probability theory, Bayesian algorithm, random variables. That's, you cannot ignore that. It's the thinking operating system of AI. And then from there, you need to know programming skills. Before, it was a little bit more challenging. We started hosting bootcamp in 2015. And biggest challenge which I was seeing for people coming from non-tech background is the programming. Now with ChatGPT and large language generative model, you can generate code. But generating code is one thing, understanding it, to use it is another thing. So you need some fundamentals. So put some time there. From there, you can get into machine learning, then natural language processing. Then visualization. In our experience, a lot of people, they get into this kind of visualization tools and get very excited by putting pair plots and graphs, and they think that's good enough. Yeah, it's a good visualization feature engineering tool, but the whole set to really go deeper this is the roadmap. So from there, you can go into, you need to understand, big data concepts. What is SDFS, what is Hadoop, a little bit. If you are targeting to be a scientist, you have to understand a little bit data engineering too, especially when it comes to large data set, how to deal with them, how to train them, then data ingestion, munging, and some additional too. So if you can take picture of this, that's also good. Now I'm going to dive a little bit into some machine learning fundamentals. Typical machine learning examples focus on a few things like predictive modeling for, let's say, for example, sales. Can you predict the sales? Can you predict the weather? Fraud detection, information decision-making, human resources. Now every resume is almost sorted by AI, at least rated by AI. In our organization, we do that very flawlessly, where every resume is scanned through the AI process and it gives a weight before even we see it. Supply chain optimization, there are millions and millions of use cases, but some common things if you are new to this field. So I'm going to look at a medical use case where I have a data set of diabetes, very popular one from Kaggle, and I'm going to walk through step-by-step process. How did I do that experiment? And give you some insight about it. So this is a beginner's process of what is data science lifecycle look like. You start with simply business understanding, what is a problem statement. So in this case, I'm looking at a medical condition and I want to classify if this person has a disease or not has a disease. So that's the first question you ask yourself. And from there, you go to understand what do you have. Data is the source to make those kind of decisions. So data acquisition and understanding. And once you have acquired the data, you need to do some wrangling, exploration, cleaning, some visualization, and then you will select the machine learning model to make a prediction. So in machine learning modeling, you'll do some feature engineering, model training, and model evaluation. And once you are done that, then the last part will be scoring and performance of the model. Is your model working good enough or not? That's a high-level process for the very beginners. So step number 1, acquire the data and explore it. So that's what I'm going to do here. In this process is broken down further. This is what I already talked about it. So this is if you want to go and get this data, this is where you can get it. This is taken from Kaggle, diabetic data set prediction. So this is what the data look like. It is a CSV file which I brought in. It has gender, age, hypertension, heart disease, smoking history, BMI, and more columns. Then I brought that data into an Google Colabs. If you are new to it, you can go to Google and type Google Colabs, and you get this Python sheet where you can start typing the code without doing any installation. All you need to do is import these libraries. So I'm going to use here scikit-learn, matplotlib, and cbond. These are packages. Scikit-learn is used for machine learning, matplot is for visualization, and cbond is for pandas and other things, data frame. So this is what I'm doing. I brought the data in by just writing pd.read CSV. And this is what the data set look like: pregnancy, glucose, blood pressure, insulin. So it's like your SQL. Step 2 is, now I have the data in my experiment. I will have to understand what is inside the data and how do I look at it. So pre-processing and visualization is the next step. Excuse me. So in these steps, it's more involved than what I'm saying, and I'm saying at a very, very basic level. Data collection, data processing, and transformation. So you will never have a situation where you will have a perfect data and a perfect day. You will have to format, clean, sampling, scaling, normalization, and decomposition of the data. So you'll do that. This is how it looks like after you got the data. Like, I have now 768 rows and about 9 columns in my data set. I'm exploring it. This is data.describe is one of the functions to look at the data set. And this one gives you a standard distribution of what the data look like in terms of mean, median, distribution. So it gives a good picture of what the data is looking like. What next thing I did is I did a count plot to see what I have in terms of outcome. Y is my label count and X is the outcome. And so that's what I'm looking here. Then I did a pair plot to understand the correlationship with input and the desired output, the results which I am predicting. It looks very messy. Don't worry about it. It's just a comparison. And then this one is the more interesting, where I'm doing a kind of a heat map where I'm able to correlate between two entities like pregnancy versus our age, diabetic. So if you see this 1, what does it mean is, it's a 100% correlation. Pregnancy is related with pregnancy. I apologize. Pregnancy is correlated 100% with pregnancy. Glucose is 100% correlated. So those are all 111s. But if you look at glucose level related with blood pressure, or glucose related with blood pressure is 0.15. If you look at skin thickness related with pregnancy is minus 0.082. So this plot gives you the understanding of the columns and how they are correlated. Now I'm going first. Next step is, so just to recap, I brought the data in, I visualize it. From there, what I wanted to do is understand the dependency of the features in the data. So I did some visualization plot. And the next thing what I will do is now get the data ready for an experiment. So this is a very important step in terms of machine learning. So you take the whole data set. For example, you have 1,000 rows. You will split them into 70, 30, 80, 20 different ratios. And you will call it train and test. So train is where you are going to train your machine learning model to learn from what is in the data. And once it is trained, then you are going to test on the remaining 30% to make sure to test what results you have. So there are various ways to break down and various techniques, but in simplified way, you just split your whole data set into best is 70-30 or 80-20, and you take the major chunk to train your machine learning on it and let it learn what kind of problem it's solving, and then best 30% you will test against it is my solution is good. So for example, if you got 100% accuracy in the real-time class or real-time workshop, I'll ask people to respond. 100% accuracy is not good, because you overfitted the problem. Your training test and test is almost same. But if you got 95% accuracy, that means you bump the odds of winning is about 40% or more. So this is how you have to look at it. So this is what I did in terms of the code. It may not be very visible to you. So this is how you do the split to bring in, and you do 0.2%, this is 80% split. These are random state defined. There are various ways you can do it. You can learn through the scikit-learn library. And then I picked up a model which I will show you how to do that. Logistic regression model to do a prediction. That was about the training and testing part. Now, how to do a model selection? What kind of machine learning problem you have, and how do you perceive what kind of machine learning problem and how to choose it. So this is another very important graph or picture. You can take a cell phone picture if you are new to this machine learning world, or you can Google it, scikit-learn library, where you can get this journey. So when you start a machine learning problem, you ask yourself, first question, do I have enough samples? That means, do I have enough data? Data is where the machine learning thrives and the experiments are done. If you don't have one, just go and get more. Small data, there are ways to play around it now, but it's not a good idea to go do a machine learning on 10,000 rows data. After you figure out that you have a good quantity of data, then you ask yourself, what category is this categorical data? Okay. Then you ask yourself, is it quantitative or labeled? Can I see some difference, clear difference in the data, or can I see clear patterns of continuous data? For example, stock market, speed versus time, something like this. So if you see a difference, labeled data where you can see literacy, red or blue, 2 colors, red, blue, green, 3 colors. I'm just making up something. Then at that point, you have a classification problem. You can classify this is red and blue. If you see with time, price changing, or with speed, distance changing, then it is a quantitative data. There is a time when numbers are changing in continuous way. So that goes into regression models. If you cannot label it and it's not fully labeled, but you can still see rather than red, blue, green, orange, pink, different kind of colors. When I'm say color, different kind of data, you can cluster them now. And these problems are called clustering machine learning problems. If it is not quantitative, then you have to look deeper inside to find out. It is still continuous, but not quantitative, where it's a continuous, right? So what we call dimension reduction, you peel every layer of it and you try to find out what kind of problem is that. That's called dimensional reduction. So that's the third kind of algorithm. So regression, number one, which is quantitative. Classification is classify red, blue, what kind of problems it is. Clustering is you have multiple colors or multiple symptoms, clusters of the problem. And the dimensional reduction is you see quantitative, you just have to peel it or reduce the dimensions to get more core out of. Now, so in my case, I have a classification problem where I need to say it is a disease or not a disease. So it falls into classification problem. In my experiment, I have used all three algorithms, decision tree, random forest, and then logistic regression. I'm going to only show because of lack of time. Logistic regression was because I wanted a definite answer. So I just built the model with logistic regression, 10 split, and then I pick the logistic regression model, fit the model, and then a prediction. Now, after you've done that, it's not about how accurate it is or how great model I built. It's about to educate you guys into what's the process of machine learning. So after you've done this, you have a model now. You have to evaluate your model. As I said in the beginning, if you have a 100% score, it's not good. So how do we know that our model is good? There are various techniques to evaluate model, F1 score, precision metrics, confusion metrics. So these are a couple of things. In my situation, there's a disease or likely to have a disease or has a disease or likely not to have a disease. So all four conditions exist. So for some of this situation, what you do is you build something called confusion metrics. True positive, true negative, positive positive, positive negative, those kind of situations. So here, my predictive model is giving me score of 0 and 1, which I did. And this is what my confusion matrix brought in. 84 have disease, 29 does not have disease, 16 and 25 are in between. What possibility of having disease or not having. This is how I plot it in the heat map. So this is a big first step if you are beginner to the machine learning part. Now we are going to go into the large language model side or generative AI. So just a conceptual base, what is generative AI and how to look at it. Now we are getting to the large language model. So generative AI is the subset of deep learning, and deep learning is above machine learning, which has we build keras neuron networks. So it's too much too detailed to talk here. But from the generative AI part of it, you have to understand it's not machine learning, it's a deep learning, and generative AI is the subset of deep learning. Now, deep learning model types, there are two: discriminative, used to classify or predict, which in few years back we were trying to predict is it a cat or a dog. Typical train on a data set which is labeled, learn the relationship between the features and the data point. Now that's a deep learning descriptive model. Now generative model. Generative model is generate a new data that is similar to the data which was it was trained. Understand the distribution of the data, how it's given with an example, and predicts the next sequence of word. So word to vector, word to word, those kind of things are part of generative AI part. So discriminative technique, classification models in deep learning. Discriminative models classify dog or a cat. Generative techniques generate a model image of a dog. So it takes some inside GAN models or transformers, which are able to produce with the text and image, voice and other things. So difference between what we were trying to do predictive versus what we are trying to do now is generative. So in predictive model, you have data and label data, and you will learn the relationship as we saw in the previous one between the data and label, and your outcome will be a label. Is it a dog or a cat? In the generative model, you have unstructured content, which gets an input and learn the pattern of unstructured content, and your output is a new content. So let's look at the output, what we get through it. So in non-gen models, Y is the output. You can get number, discrete, class, and probability. In the gen model, generative AI models, you get natural language, image, and audio.